Hey guys, we are working on this imaginary and complex numbers assignment, and we did a bunch from the first section already in the previous video. So if you need some help with those, I would go back and check that video out. Now we're going to take a look at the rest of this assignment, and this should go pretty fast. But one thing I did mention in the other video that I want to mention here as well is that the purpose of this video is to help you gain mastery. Right? It's not to give you like a free pass to get through your homework. But I do know that sometimes students need a little bit extra scaffolding or a little bit extra support at home to help get through an assignment. Okay? And if that's you, that's totally fine. What I would do with this though is instead of watching the whole video at once and just writing down all my answers, I would stop the video multiple times to practice and make sure you understand what you're doing. Because the goal is to be independent. When you take your quizzes, when you take your tests, you have to have mastered these concepts and skills. So if you haven't mastered it yet because you've just watched the entire video and you haven't really done a lot for yourself, you need to go back and practice, okay? All right. So for powers of I, there's actually only 4 we need to know. We know that I to the 1 is just I. That's fine. We know that I squared is -1. We know that I to the 3rd is -I. And we know that I to the 4th is 1. Okay? If you're not sure why that's the case or why that works, I would go back to the notes. If you missed class today, that's in the notes from today. We just kind of found a pattern, and it turns out that these actually repeat over and over and over. So I to the 5th just starts over. I to the 5th is I to the 6th is -1, I to the 7th is I to the 8th is 1, and then it goes again, I to the 9th, I to the 10th, right, and so on. So there's a couple ways to do this. There's kind of a short method and a long method, and I want to show you both. Because this cycle repeats, we can just count through the powers until we find the power that we're looking for. Let me give you an example of that. So I to the 19th. Okay, so powers. I to the 1, I to the 2, I to the 3, I to the 4. Okay, then if I go back, this is going to be the 5th power now because it repeats. 6, 7, 8, 9th power, 10, 11, 12, 13th power, 14, 15, 16, 17, 18, 19. So just by counting through, you can see that when we cycle through this a bunch of times, I to the 19 is the same thing as I to the 3rd. Those are equivalent. And since we know I to the 3rd is -I, that's going to be our final answer. Now if you think about that for a second, how many times did I cycle through? Let's go back and count. So 1, 2, 3, 4, that's 1 cycle. 5, 6, 7, 8, that's 2. 9, 10, 11, 12, that's 3. 13, 14, 15, 16, that's 4. And then 17, 18, 19. So I cycled through 4 full times plus like 3 extra steps. So 4 cycles, 4 full cycles, and then we landed on I to the 3rd. Okay, what does that have to do with anything? Well, check this out. Because we have this pattern that it repeats every 4 times, what we can do is we can take 19, which is our exponent, and we can divide it by 4. There's a couple ways you can do this. You can turn this into a mixed number, you can use long division, you can use your calculator and just translate the decimal into a fraction, however you want to do it. I'm just going to turn this into a mixed number. So 4 doesn't go into 19, and the closest thing it does go into is 16. So 4 times 4 is 16, but I'm still 3 away from 19. So this is actually 4 and 3/4. Okay, so you might remember turning a improper fraction into a mixed number. So you just see how many times this goes into this. It goes 4 full times. How does this compare to what we came up with here? Well, this whole number right here, 4, is actually the number of cycles that we went through. When we divide by 4 and we get the number 4, that means we cycled through 4 times. This guy right here, I'm going to put a box around it, is the remainder. So you can write this like 4 remainder 3, 4 and 3/4, or whatever it happens to be. But this is the important number that tells you what power of I you have. Okay? So if you divide the number, the power, by 4, the whole number that you get is actually the number of times you've cycled through this pattern. And then the remainder, or like the numerator on your fraction, is going to tell you which power of I you land on. Okay. And the one thing to keep in mind here is that if you divide by 4 and it comes out evenly, then that's the same as having no remainder. So I'm going to write a little extra. So remainder 1 is I to the 1. If you get a remainder 2, that's I to the 2. If you get a remainder 3, that's I to the 3rd. And if you get a remainder of 0, then you know that 4 went in evenly, and so that's I to the 4. Okay. Another way to think about this is in terms of decimals. So if you get a remainder 1 when you divide by 4, that's the same thing as 1/4 or 0.25. Okay, if you have 2 as a remainder, that's the same as 2/4 or 0.5. If you have a remainder 3, that's the same as 3/4, only when you're dividing by 4, of course. But that's 0.75. And when you get a remainder of 0, that's 0/4, and so you're not going to have a decimal. So this is another way to think about it. So if I were to go back and do this guy, right? So I've given you several different ways to think about this. Let's say I take 19 and I divide it by 4. Okay. Now my calculator gives me a fraction, which doesn't really help me a lot. So what I'm going to do is I'm going to use this button, S to D, change it into a decimal, and it's 4.75. So in my mind, I'm like, oh, 4.75, that's 4 3/4. Sorry, you can't see my pencil. Let me back it up. That's 4 3/4, right? And so the remainder that we're talking about is 3. So lots of ways to do this. I think the best way is probably to turn this into a mixed number, or to divide it and see what your remainder is. But that remainder is going to tell you the power of I. Now, counting through 19 times isn't that big of a deal. But what about counting through 53 times? You may not want to do that. Now, of course, you could. You can go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And you can keep going until you hit 53. The better way to do it is to just divide 53 by 4 and see what we can come up with. Okay? So does 4 go into 53? Well, it doesn't. But we can get close. We can get it to 52, I believe. So let's see if 4 goes into 52. Okay, it does. So 4 goes into 52 13 times, but we want to get to 53. So there's a remainder 1, or in other words, we have 1 out of 4. So my remainder, when I divide 53 by 4, is 1. If you were to do it 53 divided by 4, you're going to get this fraction, turn it to a decimal, 0.25. Again, that's 1 out of 4. So we're looking for that top number. The remainder here, however you slice it, is 1. So I to the 53 is the same thing as I to the 1, which is we're just going to write as I. So whenever you have powers of I, it's one of these 4 things. There's only 4 options for a power of I. So if you're taking a test someday and it's a power of I, you can kind of take a guess. It's a 1 in 4 chance you get it right. But the better way is just to know, what you're doing. Divide by 4 and see what your remainder is. Okay, again, 110, pretty big number. We may not want to count to 110, counting through this cycle. So I'm just going to divide it. Okay, now that gives me 27.5, which I know is 27 and a half. But here's the tricky part. I don't want half. I want how many fourths. Okay, so that's a little tricky, because usually as 0.5 we write as a half, but remember we're talking about what the remainder is when we divide by 4. So we want to know how many fourths it is. Okay, and 0.5 is 2/4. That's one way to do it. Another idea is you can just kind of figure out what 4 goes into. The closest thing I think is 108. Yeah. So 4 goes into 108 27 times. So you can say, okay, 4 doesn't go into 110, but it does go into 108. So 27 times 4 gives me to 108. The remainder is 2. I have 2 left over to get me to 110. But that's what we're looking for. Okay. So the remainder is what we're after. So I to the 110 is the same thing as I squared, which is equal to -1. Okay, now, if you're watching this video, I just did 3 in a row, okay, and you might be getting kind of complacent, like, oh, sweet, he's just going to give me the answers, I'm just going to write down what he says. Okay, we don't want to do that every single time. Maybe for the first couple, but we should be processing this. We should be getting better at this. We should be becoming independent. Okay, so if you haven't done any of these on your own, now's your chance to do it. Now's your chance to try on number 12. Okay, so divide it by 4, see what your remainder is, see what you can come up with on that guy. All right, if you want to go back and check it in a minute, you can. But right now, you should pause the video and you should try number 12 on your own. Okay, did you do it? Did you actually try? Remember, you're trying to become independent. If you got it wrong, that's okay. Just see what you came up with. All right, so 40 divided by 4 is 10, and there's no remainder, right? If you do it on a calculator, there's no decimal point. It just goes in evenly. And so when we get a remainder 0, what that means is that it was divisible by 4, right? It perfectly went into 4. And so in this case, what we want is I to the 4th. It's equal to I to the 4th power because 4 went in perfectly. And I to the 4 we know is 1. So kind of crazy, but I to the 40th power is actually just 1. Okay, I to the 14th, I'm going to let you do on your own. Okay, that's number 13. You can do that one. I'll do one more with you, but again, the whole goal should be becoming independent. Okay, so don't rely on the video. You should pause. You should try both of these. Then you should check your answer to number 13. See if you got it right. If you didn't, go back and see if you can find out where you made a mistake. That's a big learning opportunity for you. If you still need help, go back to some of the previous examples and practice. See if you can, maybe you have the wrong idea. Or you can check out the next piece I'm going to do, which is 14. So try it before you check. Try it before you just watch it, because it's gonna help you learn better. All right, what's 23 divided by 4? Well, 4 doesn't go into 23, but it does go into 20. 4 goes into 25 times, and there's 3 left over. So 5 3/4. What we really care about is this number, the remainder. Right? The remainder was 3. So what this means is we cycled through this thing 5 times, and then we landed on I to the 3rd power. So I to the 23 is the same thing as I to the 3, which is actually -I. Okay. All right. Now the next problem set here, we're just going to be doing what we call arithmetic with imaginary and complex numbers. So arithmetic, we're talking about like plus, minus, multiply. Divide would be included in arithmetic, but we're not going to divide in this problem set. So we're really just adding, subtracting, multiplying, that kind of thing. So the main key here is to treat I like a variable for as long as you can. If at the very end you get a power of I, we know how to deal with that. Okay, but sometimes you won't. So really, a lot of these problems, especially 15 through 18, they're just imagine you're working with any other variable. And 15 through 18 is essentially combining like terms. Okay, so let's take a look at a couple of these. All right, so 15, we got 8 plus 4i. Now this right here is one way to write like a complex number. This is a complex number that has a real portion and an imaginary portion. And so what we have here is this is actually 2 complex numbers, like the difference of 2 complex numbers. So if you recall when we talked about complex numbers look like this. A to the bi, or a plus bi, where a is a real number and b is a real number. But keep in mind that either of these, a or b, can both be 0. So you could have like 4i, right? That's the same thing as 0 plus 4i, and that's still a complex number. You could also have something like 3 plus 0i, which is actually just 3. So every pure imaginary can be written as a complex number. every real number can be written as a complex number. So every imaginary number, every real number are all complex numbers. But there are some complex numbers that you can't write as just a real or just an imaginary. They have both pieces. Okay. So the most important thing here to recognize is that both of these terms have to be subtracted. Okay. So what we need to do is we need to basically distribute that negative. So we have 8 plus 4i, that's fine. And then we're subtracting a negative 2, but we're also subtracting a positive 4i, if you want to think of it that way. So notice how this negative is basically distributing to both of these terms in here. So we have an 8 plus 4i minus negative 2 is going to give us a plus 2, and then minus positive 4i is just going to be a negative 4i. So now we just combine like terms. So we got regular, integers, I guess, 8 and 2, that's 10. And then we got these imaginary guys. And 4i minus 4i, again, if we just treat it as like a variable, is going to be 0i. So, something like that. But we don't usually write the 0i, we just write the 10. So this actually comes out to a integer, a real number, which is totally fine. Okay. Now, before we jump into number 16, your goal is to become independent. So, pause the video, try number 16, and then come back and check. Wow, that actually worked out really good to have the Jeopardy song playing while you were working. Wild. Okay, so you should have already tried this, right? Your goal is to become independent. Let's see what you got. Okay, now what I would do is distribute this. So this is minus negative 5. And then I have minus 6i. So I kind of distribute that negative, and this is what you should have. Okay, now find the like terms. We got a 3 and a 5, that's an 8. We got some I stuff. If we combine those, that's negative 14i. Again, we're just treating I like a variable. That's pretty much it. It could be an x, could be a y, whatever. We know it's actually something different, but we're just going to treat it like a variable. And we got it. Okay, so 17 and 18 you should be able to do now. You should be independent now. You should already be able to handle these. I want you guys to try these on your own and then check your answers. Okay? You have the answer to the odd one on your answer key, and I will give you the answer to 18 in just a second, but you pause the video, do both of these problems. You got to understand where you're at, what you know, and what you still need to practice. So go ahead and pause now. Okay, so coming back from pause. Because we don't have a subtract, we don't really have to worry about distributing like a negative. Right? This is just a plus. So we actually don't even need these parentheses. The main reason why we have them there is because this is basically, we're adding two complex numbers. So adding the parentheses there basically is just showing us that we have two complex numbers we're adding. But once we start kind of doing this combined like terms thing, we actually don't need to write them. So we have 6 plus 21i. No big deal. Okay, now we're getting into the multiply. So we're talking about arithmetic, right? We did add and subtract. Okay, let's do multiply. Now, the thing with multiply is we're going to treat I just like a regular old variable, but at the end, if it's a power of I, we're going to change it back to something that we know. So powers of I we talked about. Okay, now if this was just variables, 5x times 6x, what we would do is we would use the commutative property. We'd write 5 times 6 times x, but of course they're not x's, they're i's, but that's okay. We just treat it the same way. And this is 30i squared, using the product property, right? I times I is I squared. 1 plus 1 is 2. Okay, so we're pretty much done, but we know that I squared is actually equal to negative 1. So our last step here, after we treat I like a variable, is we just change it back into one of those four things, right? It's either an I, a negative 1, a negative I, or a 1. So whenever we get a power of I, even if it's not those four powers, we know how to change that back into one of those four things. In this case, it's a -1, and so my final answer will be -30. Now, originally, when I printed this answer key, it had an error on that one, and it said -36, I believe. One of my students from second period caught that, so thank you, Eric. Just brought it up so I could bring that to your attention. Okay, so try the next one on your own. If you needed help with 19, that's cool. Just need a little extra practice, no problem. But now you should probably be able to do 20 and 21 on your own. Okay? In fact, the multiplication by I is already done for you. So try those on your own, 20 and 21, and then come back from pause and see if you got them right. Pause it. Okay, so coming back from pause. This is just -9 times I squared, but remember that I squared is a -1. So this is just +9. -9 times -1 is +9. Okay, -144 times I squared is -144 times -1, which is +144. Right, you could have got those on your own. You know what you're doing. So don't use this video as a crutch. Use it as a tool to help you become independent. Okay, take a look at 22. So if I commute this, use the commutative property to rearrange it, I could rewrite it like this. -7 times I times I. Okay, well that's -49 I squared. And just like we did in the previous problems, this piece is -1. So this is -49 times -1, which is 49. All right, now some of these are a little bit different, but I bet you could figure them out. Like, I don't think you need somebody to walk you all the way through them. Sometimes we get scared when it's something we haven't seen or when it's in like a context that we haven't seen before, but just apply what you know. You know, apply the properties that you already have and see if you can get there. So if you need help on any of these four, that's fine. I'm going to go through a couple of them in just a second. But again, pause first, try it on your own, check your answer. If you got it right, awesome, you're becoming independent. If you didn't get it right, figure out where you went wrong, and then go back and practice more. You may need to go back and do this assignment again to have enough practice. And I know that sounds crazy, and like, who would do that, right? Who would do a whole assignment and then go back and try it again? You know who would do that? People that want to do well on the test. People that want to make sure they're mastering the material. And if that's you and you need extra practice, that's all right. It's just what you got to do. Okay, so in this case, I would probably distribute the I. Now, you might be thinking like, well, Mr. Lowry never showed me that. Well, what would you do in the normal situation? What would you do if you had 3 times 4 plus 5x? Right? This is the distributive property. So if you can apply a property, go for it. Maybe you're wrong, but you know, at least you tried something. In this case, the distributive property is exactly what we want to do. So I times 4 is 4i. Okay, I times 5i is going to be 5i squared. Okay, this guy right here, again, is -1. So this is 4i plus 5 times -1. Or 4i minus 5. Or another way to write that would be -5 plus 4i, which is actually how it's usually written by convention. We put the real number first and the imaginary number second. Okay. This one we've done something like this before, right? Let's just use the commutative property. Multiply our numbers, then we'll have our i's at the end. So -42i squared. This guy's -1, so this is -42 times -1, which is 42. Now, I totally would have expected you to be able to do that on your own by now. Okay? So, with all the examples that we went through, that should kind of make sense. You should be able to understand that. So if you're not doing this on your own yet, then you should probably go back and practice. Maybe print out an extra copy and keep going. All right, now this guy's got 3 terms. Haven't seen that before, but that's okay. Just going to apply the properties that I know. So I'm going to use commutative here. So 7 times -5 times -2 is going to be, so -5 times -2 is +10. So this is actually just 7 times 10. And then we have I to the third. Okay, what was I to the third again? Well, if you forgot, you can go back here or go back to your notes. I to the third is -I. So this is 70 times negative I, or negative 70I. So you can think about that negative I as like a negative 1 times I. So 70 times negative 1 is negative 70. And then we got i's. Okay, another one here that we haven't seen before, but again, like, don't panic. Just think of it as a variable, and that might make sense. That might help you get where you want to go. So I notice that I have a power of a product. So 4 times I is a product of the factors 4 and I. So if I apply my power of a product property, I'm going to have 4 to the third, I to the third. And 4 to the third is 64. And I to the third is negative I. So this is going to be 64 times negative I, or 64 times negative 1 times I, or negative 64I. All right, we did it. So ask yourself, now that you're done, how much of that did you do independently, and how much of that did you need the video for? Okay, if you use the video, it's okay. There's no shame in that. I'm not trying to shame you out of using it. What I do want, though, is I want you to use it, again, as a tool and not a crutch. So if you still can't do these problems on your own, you have more work to do. You need to go back and you need to practice until you can do them on your own. That's going to actually save you a lot of trouble in the long run, because you won't have to study as much for tests. You won't have to redo quizzes, right? You'll get it right the first time. So a little studying, a little extra studying every night to make sure that you've mastered skills and concepts is actually going to be really important for you. So that's how I recommend you use these videos. I hope that helped. I hope you're becoming more independent. If you have no clue how to do this on your own still, after you've practiced, after you use the video, shoot me an email or talk to me before or after school so we can find a time to get you some help, because you probably need to sit down with somebody at that point. Okay? All right. Thanks for watching. Use your resources wisely. You guys are awesome. I'll see you in class soon.